Hi everyone, welcome to Homework 2 Part 3 demonstration video where we are going to be running an energy model and getting some results. So the spot that we left off in the last video is I had this geometry modeled for my single family home. I also had set up the weather files in my Homework 2 folder. And I'm using the weather files for Spokane, but you are going to be using the climate that is assigned to you. So let's open up Grasshopper to get our energy model going. I'm just typing Grasshopper up here in the command line and hitting enter. And then I'm going to go into my downloaded Homework 2 files that I downloaded from Canvas, and I'm going to open up this Grasshopper file called Homework 2 Start. So I'm going to left click and drag that file into the canvas to open it. You should be pretty familiar with this Grasshopper file already. This is the one that we've been using in class in the demonstrations as well. So it should look familiar to you. So this is the Grasshopper file, and I'm going to zoom in to this section over here in the upper left-hand corner where it says select thermal zone. So I'm zooming in by scrolling, and the first thing that we need to do is bring in our geometry from Rhino into Grasshopper. So I'm going to right click on this BREP container, say set one BREP, and then left click on my geometry to bring it into here. Okay, I am going to now actually select everything on the canvas, all of the Grasshopper components, by hitting Control A, and I'm going to right click in the canvas and say preview off. I am also going to turn off the home layer. So I'm going to go into Rhino and turn off the home layer and the default layer. After I do that, I shouldn't see anything in Rhino. So no geometry from Grasshopper is being previewed into Rhino, and I don't have anything, any of the geometry that is in Rhino displayed. I'm going to come over here to Honeybee Visualize by Type. That's the name of this component, and I know that because when I hover over it, it says the name of it. And I'm going to right click next to the name somewhere along this gray bar and select preview. So now I can see a preview of my energy model. So that's what it looks like. And you'll remember from class, hopefully, that to set up this thermal zone that that Honeybee tool calls a room, but Honeybee rooms and thermal zones are the same thing. To set that up using this Honeybee room from solid component, we need the geometry from Rhino, which we've passed it. We need a construction set, which is being generated by this component. And we need a program that is being selected by this component. So all three of those things come together over here in this component, along with a thermal zone name, and we create a Honeybee room, aka a thermal zone. Then we come over here and we're able to add some more properties to our thermal zone. And in this component right here, we're adding apertures or glazing, and we're adding it by a window to wall ratio that is being fed in through here. And here we have north, east, south, and west window to wall ratios being fed in. And this is the component which allows us to choose if our zone is conditioned. And if it's conditioned, that means that there is mechanical heating and cooling. So right now it's false, meaning that there's no mechanical heating and cooling. I'm going to double click to turn that to true, which means that there is mechanical heating and cooling. And then this creates our energy model, and this passes it to this honeybee model to OSM component, which runs our energy model. Okay. As you might remember from class, we also need, in addition to our energy model, we need a weather file. And this is where the file path goes for the weather file that we are going to run for our energy simulation. So we just need to copy the path of the energy plus weather file that we just downloaded into this panel component. So I'm going back into homework 2 where I have my weather, and I'm going to right click on the EPW file with shift down. So if you have, or holding shift on your computer, you right click, you should see an option to copy as a path. So that copies the file path. Then we can double left click into this panel, Control V, take out the quotes, make sure that there's no spaces or returns after the W. This component won't understand the file path if there are returns. So if you hit enter accidentally, it looks like it might run, but it'll throw an error when you actually run the simulation. So let's hit backspace and hit delete a few times to make sure that there's no spaces after the W here in the .EPW ending. Okay, so that's all ready to go. And let's go back to our window to wall ratio. So in the homework instructions, it says to follow the steps in this video to run the energy model. And we are going to be running simulations with the following parameters. So the 0 simulation, or the first simulation, if you remember from class, in Grasshopper, we start counting at 0. So the 0 number simulation is going to have a window to wall ratio of 10% on all facades, and it's going to be run with mechanical heating and cooling. So we already set up over here our mechanical heating and cooling. That's being controlled by this component, but we need to set up a window to wall ratio of 10%. And what I'm actually going to do is, since we're applying these window to wall ratios to all of the sides of the building, I'm actually going to just use one component. So I'm going to delete these, and I'm going to pass this one number to 3 locations. To 3 additional locations, to the east, south, and west. And now this slider is going to control the north, east, south, and west window to wall ratio, because it's being applied 4 times. And you can test that that's working by viewing your energy model. So that appears to be working well. So I'm going to choose a 10% window to wall ratio. And instead of saying east here, we can right click. This is something that's automatically generated, this east text, based on one of the things that you have the slider plugged into. But if you want to override that, you can just right click where it says east and just type in some text. So I'm just going to type in window to wall ratio apply to all sides. So that's a little note for me. Okay, so we're starting with a 0.1 window to wall ratio, 10%, and we are running this with mechanical heating and cooling, and we've set up our weather file. So that's all we need to run this model. So let's double left click over here to run the energy model. You should see a dialog box like this pop up. And my energy model just finished running. Okay, so that is done. And now, in order to export this information, if you remember from class, we need to come down here. So these are some simulation names, name or notes that you can export into Excel. This is the city I'm gonna keep Spokane, but if you want to double left click, you can change the city name. And then this is where we're gonna have the results go. So those are the three things that you need to change over here in this section where it says gather inputs and outputs to write to Excel. Okay, so let's write some notes. For the notes, I think I'm just gonna type 30 by 40 home. For the city, this might come in handy later on when you're testing different simulations and want to keep track of the different parameters. But for now, I'm just going to write 30 foot by, I'll add foot here, 30 foot by 40 foot home. For the city, you can just double left click and change it to your city name. These are automatically going to be grabbed from your simulation parameters that you've set or from the results from the energy running the energy model. And down here, we need to give it a file path for the simulation output file. So this is where all of our simulation results are going to go. If you go into the homework 2 folder and go to output and open up this output template, this is where I think is a good spot for it to go. So you can either rename it. I'm just going to keep it the same name. And I'm going to right click while I'm holding shift to get this file path. So I'm going to say copy as path, come back to Grasshopper, double left click, paste it, take out the quotes, say okay. Okay, so now we're going to be writing all of our Excel results or all of our results for the energy simulation into this file. And those are the only things you need to change over here. And then over here, every time you write to Excel, you need to change the simulation number because that is going to tell it what row in Excel to write to. So let's type in 0 and you press the button to write. So just press the button and we got our first results. And you can see that the greens are the inputs or some model parameters that we've set up. It tells you our simulation nodes, the city, some parameters about the massing, and then the window to wall ratios that we've set. And then these are all of our results. So we see the energy use intensity, the peak cooling, the peak heating, and then it tells us the duration of the year that the outdoor temperature are in this range and the duration of the year the indoor temperature is within this range. Okay, and you'll notice that since we ran this with mechanical heating and cooling, we're seeing heating and cooling EUIs, energy use intensities, and their duration of the year the indoor temperatures are within the comfortable range are 100. And because of the way that we are, let me highlight this. And if you left click and drag, you can select multiple cells in Excel. So go ahead and do that. And then let's go over here and increase the decimal so we can see one additional decimal. And you can see how 99.5% of the time it's within this range and 0.5% of the time it's a little bit warmer. So for most of the year, it's within this ideal comfort range. So I'm going to save this. And now we're ready to run the next simulation. So what you're going to do is go back to the homework instructions and you'll see it says run it with a 30% window to wall ratio. So we'll go back here to where we set our window to wall ratio and set that to 0.3 and hit the green check. And you'll notice that every time you change something upstream, so upstream is this way of this component that runs the simulation. Anytime you change something, it's going to re-trigger it to run it again if you have this set to true. However, to export, we have a button instead of a toggle that's always set to true. So it won't export unless we hit the button. So down here, all we have to do to export is change the simulation number to 1, because this is our number 1 simulation. And we press the button. And then we get some more results. So we'll see how the heating and cooling changed with the change in the window to wall ratio. So go ahead and repeat that step for the 0.5 window to wall ratio, and I'll see you when you're done with that. Okay, so I ran the 50% window to wall ratio, and I have the results going here. So in the instructions, the next simulation after running the 50% window to wall ratio with mechanical heating and cooling is we're going to do 10% window to wall ratio without mechanical heating and cooling. So we're going to go back to the Grasshopper script. We're going to turn off this false start toggle that runs the simulations. And we're going to come here to where we set if the zone is conditioned or not, and we're going to change that to false, meaning that there's going to be no mechanical heating and cooling. And we're going to come back here, we're restarting at 10% window to wall ratio. All right, now we're ready to run again. So we're going to run the energy model. And then we are going to come down here, and this is our number 3 simulation. And we're going to hit the button to write the results. So now you'll see that this is our number 3 simulation. I'm selecting all of the cells by left clicking and holding, and I'm just gonna align left. So there's no heating and cooling. There's no peak cooling and heating since we don't have any mechanical heating or cooling. And we can see now that the indoor temperature is in these other more uncomfortable ranges, and we're mainly falling into this lower than 60 degrees Fahrenheit. Okay, so now go ahead and repeat that and run the window to wall ratio of 30% and window to wall ratio of 50% without mechanical heating and cooling, and export the results into Excel. Okay, so I ran all of my simulations. I have 6 in total, going from simulation number 0 to 5. The first 3 are with mechanical heating and cooling. The second 3, or the 3, 4, and 5, the second half are without mechanical heating and cooling. So after you get your results, then you are going to make some plots. The first one we're going to make is an EUI plot for the first 3 simulations with mechanical heating and cooling. So let's go ahead and do that. The way that we're going to do that is we are going to select the heating, cooling, lighting, electrical equipment, water system cells, and then just drag down and select the EUI results for the first 3 simulations. Then we are going to go into Insert and come over here into the bar chart option and select this option right here, stacked column. So you should get a chart that looks like this. The default is it's going to have the x-axis down here be the different end uses, but we want the x-axis to actually be the simulation numbers. So what we're going to do is select the chart and choose switch row and column. So then we'll see that the heating, cooling, lighting, electrical equipment, water systems are now being showed on the y-axis, and the individual simulations are shown on the x. And it automatically starts numbering at 1. But since we started our simulations at 0, we want to give it the proper simulation name. So we can say select data. And then here, we can choose for the horizontal axis labels, we can say edit, and this will pop up, and we can left click and drag over here for it to select these three numbers, 0, 1, and 2. And this is what this should look like when you select that. If you accidentally start clicking on other stuff, it will select the things that you click on. You just want to make sure you click on the simulation numbers, left click and drag. So it selects those three and say OK. And then hit OK. So now you'll see it says 0, 1, and 2. Another thing that we're going to do is I'm going to come back to home and I'm going to increase the font size a little bit. So I'm going to left click up here where it says the font and it has this A with an arrow pointing up. I'm just going to bump it up a little bit. You can also just change the text height by selecting it here. Okay, and then I'm going to change these colors. So I'm going to come to heating. I'm going to select one of the bars for heating here. And I'm going to go to design. Actually, I'm going to go to format, and under shape fill, I'm going to choose red. And then for cooling, I'm going to click on one of the cooling bars here, and I'm going to go to shape fill and choose a blue color. That's a little bit more intuitive. Then I'm going to click on interior lighting. You might need to zoom in to click on it. To make it easier to click on it. So clicked on that. I'm going to make interior lighting yellow. I'm going to make electrical equipment. I'm going to click on one of those. If you click on it twice, you will select only one of the instances of electrical equipment. But if you click on it once, you'll see that all three are selected. So make sure that you have all three selected when you change the color. And I'm going to click on this top one, which is water systems. So that is energy for the hot water systems, and I'm going to change that to orange. You don't have to use these colors, but these are what are most intuitive and what a lot of people use. Okay. So that is our EUI chart. We can label it annual energy use intensity by end use. And we should add a y-axis label. So with the chart selected, we can go to design and then go to add quick element, axis titles, primary vertical. So that'll add an axis title, and then we can change the axis title there to kilobtus per square foot per year. Okay, so we have a little end use chart. Now we can copy this chart, and clicking outside of the chart somewhere like adjacent to it, after you say Control-C while selecting the chart, Control-V, and you'll get that chart next to it. And we can just drag. You'll see that the data that's generating the chart is being highlighted up here. We can just drag it over. So we can just, there's a few different ways to do that. I'll just click on this upper right-hand corner and just drag that over to the right of you. And then I'm going to click on this upper left-hand corner and drag it over. And so that we're only displaying the information for peak cooling and peak heating. So now you can see that the data changed. It's grabbing the data from over here. These labels changed. They're displaying peak cooling and peak heating. The titles did not change. So we need to change the titles and the axis label. So this is actually going to be BTU H per square foot. Those are the units of peak cooling and heating, and you can see that up here. And this title is going to be peak heating and cooling. And I'm going to change this color to red. I'm also going to change this chart type. So I'm going to select this. And for peak heating and cooling, it's nice to see the bars next to each other. So I'm going to go to Design. I'm going to, under Chart Tools, go to Design after you have the chart selected, and go to Change Chart Type. And I'm going to select this cluster column chart and say OK. Okay, so this is what peak heating and cooling should look like. This is what the EUI chart should look like. And I've actually changed my mind. I think I want to show all of the EUIs for all of the simulations on this chart. Because even though we don't have heating and cooling, we do have the other EUIs, the other energy use by the other equipment or other end uses. So to do that, just click on the chart and then left click in the bottom right hand corner of this blue box and just drag down. So you'll see the EUI for simulation number 3, 4, and 5 as well when you dragged the bottom of this down. And you can see that if you bring it up, it will select, it'll reduce the selection, and it'll only display information for what you have selected. Okay, I'm going to minimize this a little bit. And then we only need one other chart, and that is the indoor temperature range. So let's actually show the indoor temperature range for all of our simulations. So I'm going to left click and hold and select all of this information right here. So I'm starting in this cell and left clicking and holding to select all of this. Then I'm going to go into Insert, choose this column chart option, and select this chart option, stacked column. Okay. So you'll see that it automatically has the individual simulations on the x-axis and then the percentages on the y-axis. So that is working well. I'm going to select the chart and bump up the text a little bit. I'm also going to change the colors of these to make them a little bit more intuitive. So this less than 60 degrees Fahrenheit, I'm going to go to Format, and under Shape Fill, I'm going to choose this, like, let's say, kind of this lighter blue color. Because to me, that means that it's very cold. It's like ice cold. You can choose other colors that are more intuitive to you. For the 60 degrees Fahrenheit to 65 degrees Fahrenheit range, I'm going to choose a blue. For this 65 to 78 degree Fahrenheit range, I'm going to choose a green. Like green is good. And 78 to 83, let's choose like a warmer color, maybe orange. And then this greater than 83, choose like a warm color, like red, a hot color. Okay. And then we can give this chart a title. Duration of year indoor temps in range. And then lastly, it started numbering our simulations at 1, but Grasshopper starts numbering at 0. So we need to renumber these. So what we're going to do is select the chart, go to the Design tab up here under Chart Tools, and say Select Data. And then for the horizontal axis labels, we're going to choose these over here. So now they're 0 through 5. So this is how we create charts using Excel for end use, AUI end use, peak heating and cooling, and the duration of the year the indoor temperatures are within our ranges. And in the next video, we are going to learn how to create hourly charts in Grasshopper and to display hourly information of the indoor temperature ranges and the energy use intensity in Rhino. For this part of the homework, you'll need to save this Excel sheet and upload it into Canvas. Okay, that's it for this video, and I'll see you in the next one.